Right, this is a common sum. The sum is, question number 15. The sum is a square plane is placed along YZ plane along this. And along x-axis, an electric field acts 3 into 10 to the power 3 Newton per Coulomb, I hat. So the question is, what is the flux through it? Simple. Electric field acts parallel to x-axis. That means electric field acts somewhat like this. First thing. Second thing, if this is the area, so what would be the area vector perpendicular to this? So perpendicular to anything that is along YZ plane is x-axis. So vector E and vector S. Vector E is given. Vector S, value and direction. Value is 10 into 10, 100. So we have to write here, this is its value, 10 centimeter by 10 centimeter. So this much meter square. What is its direction? Perpendicular to this, I hat. We had a detailed discussion on this, how this becomes I hat earlier. So this is E, this is S. So flux is given by E dot S, you remember. So E is this much I hat, S is this much I hat. Now remember, I hat dot I hat is 1. So flux would be only we will multiply this. So before that, it is 1 by 100 and that much. E is 3 into 10 to the power 3 and S is 1 by 100 from there. E dot S. So this much, and unit of flux, Newton per Coulomb for E, and for area, meter square. This area, meter square. So this is 30 Newton meter square per Coulomb. That is the flux. Now another question is asked that if the area is inclined at an angle of 60 degree, I suppose, yes, 60 degree with x-axis, then it would have looked like this, and this angle would have been 60 degree. That means this area would have been made like this with this 60 degree. So you can well understand that the area vector also becomes, it was initially like this. Now if it is rotated like this, the area vector also rotates. So you have to consider that thing. Either there is an easy way. I showed you with the shadows, you remember? So there I told you, take projection of that area. Apply the same formula, only take projection for that area. And for flat surfaces, I told you the projection should be cos theta times. So the flux in the second case, phi 2, if the area is rotated by 60 degree, then it would be 30, initially it was into cos theta. 15 Newton meter square per Coulomb. That's it. What is this now? This is a cubical surface. Q. These arrows represent their area vectors. Now try to understand this. If I draw electric field in this direction, and if I place this Q along the direction of the electric field, try to understand this carefully. If the flux, that is electric field lines, hits the box like this, can you see the direction of this arrow? This arrow and electric field are opposite in direction. That means, you know it very well, E into S, area of this surface, into cos theta. Cos theta becomes cos 180 degree because this direction and this direction is 180 degree. So EDS cos theta will become negative. We discussed it earlier also. So incoming flux, did I tell you earlier? Incoming flux is negative. But if the electric field continues like this, so this bechara, this direction, consider this. Electric field is along this in this direction, positive x-axis. The area vector is also along positive x-axis. So the direction makes 0 degree with the direction of electric field. So here E ds cos theta becomes E into S only. Cos 0 degree is 1. So this is what? ES. Here also it will be ES because cos 180 degree is minus 1. Only the sign will be negative. So let us brief it again. For this surface, flux entering is taken as negative through this area. But for this surface, opposite side, flux leaving, flux through this would be positive for this surface. Flux through this would be positive. So for flux leaving positive, flux entering negative. Also consider other 4 surfaces. Surface number 1, this one. For this surface, you see for this surface, electric field and area vector perpendicular, cos 90, 0. No flux passes through this surface. This surface. For the back surface, same thing happens. Electric field and direction of area vector is 90 degree, flux 0. So how many surfaces are there that flux will be 0 for this electric field along x-axis? Surface 1, surface 2, surface 3 and surface 4. Here also electric field and area vector 90 degree. Here also electric field and area vector 90 degree. So these 4 surfaces, 1, 2, 3 and 4, flux is 0. Flux is negative for this surface, first surface, flux is positive for this surface. There has to be this clear idea first. Second idea. First idea, I think you have understood. Second idea. This negative flux would be E into S. This positive flux would again be E into S. Now, if it is a cube, this S area of this surface and this S area of the opposite surface will be equal. So for that, what will happen? S are equal. Now if E here, electric field, and E here, electric field, are also equal, then flux entering equals to flux leaving. So in that case, net flux would be 0. But if certain thing happens that the electric field is not uniform, that means here electric field is E1 at the place this surface is at, and electric field at the position where this surface is, their electric field is E2. So here flux outgoing would be E2 into S. S means area of this surface. And here flux incoming would be E1 into S. E1 here into S. So E1S and E2S. So for this, there would be a net flux. Whatever would be greater. Suppose E2S is greater. This E2 is very naughty, always trying to fall. Anyway, so E2S is greater than E1S. So flux, outgoing flux would be greater than incoming flux. That will mean this box has a charge inside it. If net flux is not 0, then there must be a charge residing inside it. If the net flux is outgoing, then the charge should be positive. And if the net flux is incoming is more, outgoing is less, then incoming flux more means incoming flux becomes negative. So the charge residing inside it should also be negative. So these are the ideas. Before you start, next, sum number 16 and sum number 17. So I suppose that you understood the question number 16, that net flux should be 0. Now let us be back to question number 17. There it is said that the net flux is outgoing. Net flux is outgoing. Now tell me, just now I have told you, net flux is outgoing. Outgoing flux is always positive. So if net flux is outgoing, obviously it is positive. So a positive charge resides inside that box. Simple thing. And next part is how much charge resides, positive charge, how much positive charge resides inside that box. For that, let us apply Gauss's theorem. According to Gauss's theorem, flux should be equals to Q by epsilon naught. So from this we can find Q as phi into epsilon naught. So phi is given as how much? 8 into 10 to the power 3. Phi. And epsilon naught, we know this. Epsilon naught is 8.85 into 10 to the power minus 2. So I'm writing here. So finally it becomes this into that, that means it comes this much, equals to 7.080 into